Hello everyone, my name is Onkar, your host for today's video. So in today's video, we are going to dive into fascinating world of digital electronics and let's explore one of its key component, that is multiplexer. Specifically, we will be looking about 8 raised to 1 multiplexer, which is widely used in various applications. So let's get started about this. So before jumping into directly working of 8 raised to 1 multiplexer, let's quickly review the basics of multiplexer in general. So a multiplexer is often abbreviated as MUX, is a digital circuit that allows us to select one of its data input from multiple sources and route it to a single output. It's like having for uh, a traffic controller for data system for data transfer. So basically it accepts several data inputs and allows only one of them at a time to get through the output. Means if we apply multiple signal to this eight to these pins, input pins, so if we select one of the pin, then only that pin signal get passed to output. Other input, we don't pay attention to them. So that's the working of multiplexer. And for selecting the output which we want to desired output we want to get, we use select lines for this to get our desired output. Here we using the IC 74SC151 or 74SCT151, that is 8 channel multiplexer that's have 8 input and 1 output and 3 select line, that is ABC, and one uh, active low enable input, and we get a output at Y terminal, and also we get inverted output of Y at W terminal. So let's see pin diagram. Oh, before we see pin diagram, here is a real-time example of multiplexer. So we have all of us see that in our home, that is a stereo system was there. So in that system, if we want to play music from, there was an option that like radio tuner, cassette tape, compact disc, or DVD. So we can select any of them, and that out input we get to the loudspeaker, that is output. So this is how the multiplexer we use. Also here are other application of multiplexer, that is data routing, address decoding, data selection, arithmetic function, code conversion, display multiplexing, and programmable logic. So in this experiment we have used components that are IC74SCT151, some of the connecting wires. Basically we have made circuit on breadboard, and also we have made the simulation of Proteus. Also we require DC power supply 5 volt, breadboard, switches, resistors, and LEDs. Uh, in procedure, we have to verify the all components and wires that we are connected, that in a good condition are connected neatly. Then make the connection shown in the circuit diagram. Uh, I will I will show here that the circuit diagram, how to make the circuit diagram, and provide the data input to switches, that is input, and verify the truth table and observe the output. That's all about this multiplexer experiment. So let's see a pin diagram. So in this pin diagram, first number pin is D3, means input 3. Second number pin is input 2. Third number pin is input 1. Fourth number pin is input 0. And at 5 we get an output, and at 6 we get an inversion of output. At pin number 7 we have to apply the active low signal, that is enable signal of this IC. 8 number pin is of ground. C number 9, 10, and 11 are the select lines that represent A, B, C. 12 number is input 7, 13 number is input 6, 14 number is input 5, 15 number is input 4, and 16 number is VCC. So this is the pin diagram of IC74SCT 151 8x1 multiplexer. So here is the main part about this functional diagram. This is a functional diagram of 8 by 1 multiplexer. So we got the input here from D0 to D7, and A, B, C are select lines that we select the input which we have to get to the output, and this is the enable pin of our IC that is generally made to be active low. So here the output we have to get that depends about this select line A. Here one concept is main, that's are select lines. So whenever we select the input 0 0 0 means this ABC we set to 0 0 0, the D0's input gets selected to the output, and when we apply 0 0 1, then D1's input get applied to the Y. This is how the multiplexer works. Here is a truth table. We have to see, we have to check from Proteus simulation. Here is a circuit diagram of how we have to connect the circuit, verify the truth table. So let's get into the Proteus software to see how it works. So here we go. This is the circuit that I have made on a Proteus software. So here I have taken components like logic toggle, LEDs, aqua for identification, and 7 for SC151 IC. So this is the connection I have made. These are the select lines A, B, C. This is the enable pin that I have connected to ground, because reason is this pin should be active low. These are the two LEDs. So Y bar is our inverted input, and Y is means D2's LED is our original output. And here are the select lines from X0 to X7 from pin 4, 3, 2, 1, 15, 14, 13 and 12. So let's verify the truth table. So press this button, run the software, run the simulation. So at initially we have applied 0 0 0 logic to the select line ABC. So if we select 0 0 0, then our X0 is selected, means pin X0 is selected. So if we apply 1 to the pin, then we got output at Y, and other condition are don't care. If we apply 1 0, another 2 1 0, that does not affect our output, means other than X0 all condition are don't care. So if we push it to 0, then LED will turn. Same like this. So at second condition, if we apply A pin 1, if we apply 1 to A pin and 0 0 to B and 7, the X1 is selected. Means if we give input 1 to X1, then output we get at Y. If we give 0, then it will give inverted output, that is at Y bar here. This is how we have to test the multiplexer. So let's verify the truth table. At initial condition, at first condition, we have applied 0 0 0. So if you apply 0 0 0, then the X0 is selected, and if we apply 1 to the input X0, then that input is we have got to the output Y. And if we give 0 to X0, then inverted output Y bar is get here. Likewise, if we at second condition, if we give 8 to 1, then the X1 is selected. So here we apply 1, then we get output at D2. Same as at third condition, we have to apply B to 1 and other A and C to 0, then X2 is selected. Here it is. Same as if we apply 1 1 to A and B and C to 0, then x3 is selected. That means this pin. After that, if we apply AB0 and C to 1, AB0 and C to 1, then x4 is selected. This pin. Here is one. Likewise, we have to set at 6 condition. We have to set A to 1, B to 0 and C to 1, then x5 will be selected. And at 7 condition, A to 0 and B and C to 1 and 1, then x6 will be selected. Here it is. Also, other than this pin x7, x6, all are don't care condition. If we that do not disturb the output that we have applied. So at last condition, all ABC we have to set at 1 1 1, and then x7 is selected. Here it is. After this, we will see actual circuit and its working.
So this is our actual working model. So here is our power supply. It is 5 volt DC. So from here we have provided input to this DIP switches that works as our logic state. From here it goes to the IC. Here is our IC. IC is 74ECT151E. This is pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have provided the circuit diagram in a Proteus software as same as this. I have connected here, and our output will be taken here. This is our Y, that is our actual output, and this is Y bar, that is inversion of Y.
So let's verify our truth table. First of all, we have to set ABC to 0 0 0, then D1 D0 is selected. Y we have to got output. Then A is 1, BC is 0 0. Then D1 is selected. D1 is high. Then Y we got output at 1. Then A is 0, B is 1 and C is 0. Then D2 is selected. Then A and D is 1 1 and C is 0. Then D3 is selected. At Y we have got output and at Y bar is 0. Then AB is 0 0 and C is 1. Then we have to got output at D4. Then A is 1 and C is 1, B is 0. Then we have output at D5. Then A is 0, B and C is 1. Then we have to output at D6. Then both A, B, C are 1. Then D0, D7 is selected. This is how our circuit works. Thank you for viewing this video.